Problem number 60, page 691, acid-base chemistry. In this problem, you're told that 50 milliliters of HCl and 20 milliliters of HNO3 are going to be diluted to 300 milliliters and then diluted to a final volume of 1 liter. Information about each chemical that's given. We're told that the density of HCl is 1.19 grams per milliliter. We're told that the density of HNO3 is 1.42 grams per milliliter. We're told also that of the 50 milliliters of HCl, it's only 38% concentrated, meaning 38% of this volume is actually HCl, the rest is water. And then the 20 milliliters of this HNO3 is 70%. We are asked to calculate the hydrogen ion concentration, hydroxide ion concentration, and pH for the solution. To determine the hydrogen ion concentration, we're going to need to know how many moles of each chemical is present in the initial sample. The first thing I'm going to do is determine the mass of HCl. Knowing that the density is 1.19 grams per milliliter and there's 50 milliliters of the sample, we can use the density to calculate the mass. So 50 grams of HCl has a mass of 59.5 grams. Performing the same calculation for HNO3, using the density and the volume given, we have 28.4 grams of HNO3. Now this 59.5 grams that we just calculated of HCl is not all hydrochloric acid, HCl. Only 38% of it is. Since only 38% of this mass is hydrochloric acid, we have to multiply the mass by 0.38 to get to know that 22.61 grams of HCl is in this 50 milliliter sample or amount. 70% of the HNO3 of this 20 milliliters is actually HNO3. So multiplying the mass of the entire 20 milliliters by 0.7, then we know that there's 19.88 grams of HNO3 in 20 milliliters. So HCl and HNO3 are strong acids. They're going to completely dissociate. So from the mass, we need to convert it to moles and then figure out how many moles of H plus will be present in our solution. So converting the mass of each chemical to moles. When we started this problem, we were told we had a total volume of 1 liter of solution. So now I'm going to convert moles to molarity by dividing by the volume. Since we have a 0.62 molar solution of HCl, and HCl is a strong acid, it will completely dissociate. That means we have a 0.620 molar solution of H plus contribution from the HCl in solution. When the HNO3 is put into water, HNO3 is also a strong acid. It will completely dissociate. So if we started out with 0.316 molarity solution of HNO3, we're going to end up with a 0.316 molar solution of H plus contribution from the HNO3 in the 1 liter solution. Since the HCl and the HNO3 were mixed together, the total hydrogen concentration of the entire solution is the addition of these two. So 0.62 plus 0.316 equals 0.939. That is our concentration of H plus. We've just calculated the concentration of hydrogen ion H+. Using the pH equation, pH equals negative log concentration of hydrogen, we're just going to substitute in this number into the equation and calculate the pH. We're now going to use the hydrogen ion concentration that we just calculated to determine the pH using the pH equation. Substituting, calculating the pH, 0.027. To calculate the concentration of the hydroxide ion, we're also going to use the concentration of the hydrogen ion. We're going to use the Kw expression. The dissociation constant for water. Substituting the values into the equation and calculating for OH-. Hydroxide ion concentration 1.06 times 10 to the negative 14 molar. Here are the solutions to this problem. We have the concentration of H+, the concentration of OH-, and the pH. Any questions?